This is 99% Futurism Forecast. Here, I talk about futuristic technologies. So, today, I am going to talk about supremacy of quantum computers. Let's go. Today, I will talk about quantum supremacy. Our classic computers we use today will be replaced by quantum computers. Quantum mechanics deals at the level of atoms and electrons and making crazy equations. Let's take a look at 3 of the most amazing quantum breakthroughs in revolution that are bringing a next level of liberation and freedom to the world of science today. At first, Chinese scientists claimed that they have constructed a quantum computer that has the ability to perform certain computations almost 100 trillion times faster than the world's most advanced supercomputer. Perhaps this could be the mother of all supercomputers. According to reports, the researchers have constructed the first ever quantum prototype that is much faster than the current supercomputer. In fact, the research itself was published in Science magazine. This research gives us a light on quantum computational advantage, which is also famously known as quantum supremacy. While the project might still be in its infancy, quantum computing is seen as the potential to radically enhance the power and speed of computers, giving them the ability to simulate much larger systems and make mind-blowing advances in the field of chemistry and physics. But it has become a tech race between Chinese researchers and some of the largest U.S. tech corporations such as Amazon, Google, and Microsoft. For example, Google announced in 2019 that they have constructed the first quantum computer that was able to perform a computation in under 200 seconds, which would take the world's fastest supercomputer at least 10,000 years to complete, thereby claiming quantum supremacy. But there is new Chinese prototype would be able to process 10 billion times faster than the Google prototype. Yes, the Chinese government is investing heavily in quantum research. In fact, President Jinping's government is building a national laboratory of China for quantum information sciences that will reportedly cost $10 billion, a state where a quantum device can solve a given computational task faster than world's most powerful supercomputer, while the researchers are yet to conduct the actual quantum experiment. The article that they published in Science Advances proves that their chip produces a quantum mechanical resource that could be used to achieve quantum advantage. To get to this desired state, it requires that one has the ability to control about 50 quantum bits, which is the quantum physics equivalent of the binary bits of zeros and ones used in classical computers. Currently, researchers are confident that they will use their photon research to construct a new and more advanced simulator to solve complex biochemical problems that might be used in the creation of new medicines. That being said, they are confident about taking the next steps for the technology to become a reality. The major advantage of light-based quantum computers is that the technology is already put in place for enhancements to be made. This includes increasing the number of qubits available to advanced photonic chips that are used in the telecom industry. A serious challenge, however, in generating photon qubits has got to do with maintaining high quality. This is exactly where the Copenhagen researchers achieved huge success. And lastly, there is another breakthrough by IBM. According to a groundbreaking study published in Physical Review Research, a group of University of Chicago scientists has announced that they were able to turn IBM's largest quantum computer into a quantum material itself. They programmed the computer in such manner that it was able to turn into a type of quantum material known as an exciton condensate, whose existence has only recently been proved. Such condensates have been identified for their potential in future technology, mainly because they conduct energy with almost zero loss. The reason that this quantum breakthrough is so thrilling is that it gives you a feeling that quantum computers can be used as programmable experiments themselves. This could therefore serve as a workshop for constructing potentially useful quantum materials. Physicists are particularly interested in these types of new physical states, mainly because these discoveries are essential in shaping the development of game-changing technology. For example, one particular state called a superconductor forms the basis of MRI machines, despite the fact that exciton condensates had been predicted half a century before. Recently, scientists have been able to actually make one work in a lab without having to resort to the use of extremely long magnetic fields. However, they still continue to impress scientists because they can transport energy without losing any of it at all along the way, something that no material discovered has been able to do this. If scientists can be able to understand them better, that would be the key to creating incredibly energy-efficient materials for an exciton to condensate. It must be created from a lattice of particles and then cool down to below -270 degrees Fahrenheit. It's then coaxed to form particle pairs, known as excitons. They then make these pairs become entangled because of the complexity of this method. Scientists have only been able to make excitons condensate a few times. Now see how quantum computer at IBM can be used. This quantum computer is available for people all over the world to test their algorithms, and so a duo of students, Leanne Sager and Scott Smart, has come up with a set of algorithms that analyze the Rochester quantum bits as an exciton. This quantum computer works by entangling its bits so that once a computer becomes active, the entire thing becomes an exciton condensate. This complex study therefore demonstrated that quantum computers can be utilized as platforms for analyzing exciton condensates on a more complex level, processing the ability to program a quantum computer so that it's able to behave like an exciton condensate might prove extremely useful and amazing when you consider the potential of exciton condensates for being used as energy-efficient materials. Aside from that, the ability to program such a complex quantum mechanical state on computer will be marked as an impressive and game-changing scientific advancement because new researchers are still exploring the extent of which we can perform. But one thing that scientists have known for quite a while now, there are certain natural phenomena that are virtually impossible to analyze when using classical computers we are using today. So, this was all about the researches in quantum supremacy. If you want to contact me, there are links in description. Make sure to follow and subscribe us, and also turn on notifications to never miss our content. Stay tuned.